you've probably noticed with your projects and what you've been working on, JavaScript has some similar syntax now where you can use the class syntax, and JavaScript classes work totally differently, but it's a similar, you can at least kind of flex that muscle memory from that perspective. So do we have any questions about classes? At least from a general overview. Yeah, John.
So I think from what I gather, the constructor part of the class, is that only the part that's concerned with like setting the key value pairs for the initial state? Or I guess what would be, because I always thought of constructor as something like a function that builds objects, right? That's how we learned it in JavaScript. Is that a similar sense in constructor part of a class in Java?
You want to take that, Drew?
Yeah, basically, you're right. The constructor is what initiates the object. Once you create the object, it will automatically run the constructor. And so you can build key value pairs in there. You can build completely different functions. You can build children in there. There's a lot of things you can do with constructors. But the main thing is, it's just what is going to run once you build an object every single time.
Right.
So.
Yeah, when you instantiate a new class, the constructor is called 100% of the time. And whatever the constructor is instructed to do, sometimes it's just build an object, sometimes it's set methods, sometimes it's who knows what. That is the constructor is what runs every single time. And so those are the things and thoughts that you need to put into what do I put in my constructor. So if there are values, like in this case, we need to set the username, set the email that we're setting up for the user. Yes, they go in the constructor.
And that from a default constructor to build specifically create one. It has one anyway. That's called no parameters. Initiate them own.
You can have default values. It's not a default constructor.
Well, like what I mean is when you create the class, you don't create that constructor specifically.
If you don't create a constructor in a class, you're doing it wrong.
Right, you should. You should, but if you don't, it won't migrate. You have the simplest of classes.
Yeah, not every class is building objects either.
Right.
Some classes are just going to be utility functions or things like that. So
parents that send down
right.
stuff for childhood in there.
Exactly. So there's going to be instances where the constructor really isn't used, but for the most part, you should always have a constructor that's doing something.
You can have more than one.
Yeah, if you want to. Yeah, there's all sorts of nuances and things like that to get into it with those, but cool. Any other questions? All right, great. So two things I want to hit really quick just to make sure that we're on the same page. So today our conversation is going to be principally around talking about object-oriented programming. So we're going to be diving into more thought processes in that sense than introducing tons and tons of new code to you. Java is an object-oriented language. When I say that, what do I mean? What do you hear when I say Java is object-oriented? What does that mean to you?
Objects.
It needs objects? Objects are good. What else does it need? What else does it mean? Structure.
The entire code base is wrapped inside objects.
Okay. Okay.
You have to view everything as almost physical, right? That's the way I learned it. I was trying to explain this in Thursday's class too. So it's like it's different from the way we know JavaScript. Like think of Java and object oriented. You have to almost envision everything that you create in pieces as to, like, I use the example of like creating a chair object, right? You have to break that down into like, what does the chair have? Well, it has legs. So every chair, like when creating a class, you're basically generalizing chair has legs, so legs would be attributes of chair, or seated, not seated, as a movement type thing. I know that makes sense, but I'm trying to like.
Yeah,
I'm
no,
trying to
that's actually,
verbalize how I
that's
see
a
the
really,
object.
that's a really good way to think about an object-oriented system. The object-oriented programming is predicated on the fact that larger pieces of functionality can be broken into smaller pieces of functionality. So using Caesar's chair model, if we declared a packaged chair, this is going to be a collection of classes. We could have a class that is a leg, and that leg provides the functionality of a leg. You're going to have multiple legs on a chair, hopefully, unless you're very good at balancing. You might have a class for crossbeam. You might have a class for the back. You might have a class for the spindles. You're going to break things down into small pieces, and then those pieces become collections, essentially, that build larger things. That is the object-oriented programming and design is predicated on breaking things down into small pieces. We've been doing that in JavaScript because it's a good programming practice. We're not doing it because of object-orientedness, but it's a good programming practice to do that. So you already are familiar with how things should be broken down, at least from a thought process. Think about your functions, you think about your objects, you think about your libraries. You want them to be simple. Rule of thumb, a class should have one job, and they should do that job very, very well. If that job is, like Drew mentioned earlier, just to give information to a child class, then that's what it does. We don't worry about putting other functionality or things in it. So the biggest piece and a major takeaway there is just to take and break everything down. So we all know that objects can have functions on them, right? Okay, a function on an object is called a what? A method. What's the difference between a method and a function?
JavaScript.
At all. It's more universal. So basically the gist is if a function exists on an object, it's a method of that object versus a function that exists in like a helper file or something like that. So methods are functions, functions are methods for the most part. You can use them almost interchangeably, but that's one of the key things that come across. Fields on classes are attributes, so data types, things like that. Let's see here. All right, cool. Let's dive right in. So we need to build some stuff, right? So we have, sweet, a nice set of files. Let's look at these files together really quickly. Triangle, test, and square. So we have two basic classes that exist. There's not much in them quite yet because we're going to build them out. But we have a square class and we have a triangle class. We have a set of tests. These are unit tests, essentially, that we would run against our classes. And then we have a build.sh is a shell script, so something you can run. It just compiles everything. You guys know how to do that. Our goal is going to be to have these tests be able to pass within our classes. So in this case, when we instantiate a new triangle, we can print out a square area, we can print out a triangle area. We can print a square perimeter, we can print a triangle perimeter. You guys are all familiar with squares and triangles, right? So what we'll have to do is build attributes and methods for these classes so that these tests would pass. So what I'm going to do is just send these out to you. I'll leave the structure up on the screen so that you've got it available to you. But the goal is to build out these classes. So work in pairs, work as a group, do it however you like. Take those files, take 10 minutes, and try and get those tests. At least in theory, we're not going to necessarily run them Or at least in theory, you want those tests to be able to pass. So I'll be back in a minute. Yeah.
I see it's on it.
Yeah.
Yes, once you open that up, it'll run it. I mean, you can just run the command yourself. You don't have to.
Yeah, there's a lot of places that I mean,
Yeah. What? Actually, I've been working through some stuff online, like different things, just like code practice things. Yes, that's the last thing I worked on before I No, I'm shocked that I don't remember. I was like I remember the basics of the classes and why I didn't upload the file. That is the way it is. I don't remember like anything else. Really? Yeah. I'd say, yeah, just like one job. I think the craziest thing we did was nested tables. That was like, I honestly can say, yeah, that was like the craziest thing we did. Yeah. It's a little inefficient.
Sitting around the wall.
Yeah.
So that's done.
Yeah. Yeah.
You just need to specify. There should be a way for you to use your email ID. Whatever. Just because it's on just to see the servers, because this television servers. Yeah, the servers.
Yeah.
Really? It's not, you can't use it. That would make, that makes sort of sense. It's just my first instinct as far as it could be Just because doesn't mean there's a back end of see this or think about how does it store it? So it doesn't store.
How we doing?
Save as is. All of these little notice of scenes between save and inside the data.
Yeah, please do work in groups on these things. I know Java is a big, daunting thing sometimes, so remember, you're just trying to build a triangle and build a square. So think about the attributes those need, And then if you look at the test.java, you see the methods that you may need to build. How are we doing over here? Team? It's very similar. Not, I mean, there's nuances, but like C# has generics? Yeah. Okay, yeah. It's Go that doesn't have generics, that's right. There's something else that C# doesn't have that Java does. It's along those same lines. How we doing? Feeling okay? Can we build a triangle? Build a square? Yeah. Okay. Well, so think about it this way. Think about how you build it with JavaScript. How would you create? So in here, if you look at the triangle, for example, you want to get height, like side length after side length has get height. So when you map dot sign, map dot 2 radians, that's what goes up to Java. This is exactly what it's nice to do. But there's some equation there with side length. So you probably need a side length variable for your triangle. And what is the side length going to be? Would it be a float, a double, an int, a string? You just want a solid int. There you go. Int side length equals 10 or whatever. Yeah. So think about it that way. How is it we create a side? Now we need to figure out a way to do, if you look at that as a test, again. Let me bring up the test. So this is the test, essentially. We see that we build a new triangle and a new square, and then with the triangle, we calculate an area, we calculate a perimeter. You know how to calculate an area of a triangle, right? That's why 1, 3, 4, 5. You can now calculate a perimeter triangle, right? The side length times possibly to make it just a, isosceles triangle. So that's all you have to do. Break it down, think about that. What fields, what values would a triangle be? A square, what values would a square be? How would we call these methods? Let's build those methods on the object. Cool, makes sense? It's just a shell script. So dot slash build process. And make sure it's executable. So you have to we need to give it the class path. So in this case, the class path is one. So yeah, so if it's in the shapes, probably it's probably yeah. Look at, if you look at your classes and see where the yeah. So you can go through those. Errors are great, right? Take just a couple more minutes. See how far you can get. Remember, break it down. The cornerstone of OOD, object-oriented development, is breaking things down into small pieces. Small. Think about a triangle. How do you make a triangle? Think about a square. How do you make a square? If you are really clever, you can make a line class and then have both of the other classes extend the line class. Oh, I was thinking about that. Then we're talking about polymorphic classes. That were really cool. If you wanted to get really cool, you could make a dot class. And the line class would extend the dot. Scary. Because think about it, what's a square? A square is just a collection of dots. Organized in 2 lines. How are you doing over here? Figuring stuff out? If you don't use access, it doesn't work. So think about this. So if you have a size, you have a size of remember, you're going to, well, because you're going to have to call a new triangle, you're going to give it a value. That value have a constructor in your class, and that class will assign the side length, and then you can have whatever else you want. Does that make sense? It's a function that takes an argument, and that argument becomes values.
In my class, I would make
It's just and that's called a constructor. Constructors are just yeah. Here, let me put something on the screen to help you. So yeah, you just use the data guide. That was right.
Yeah.
Yeah. So here you see there's a constructor function. You input class, so it's takes a string and then sets those. So in this case, right. Constructors don't do that. Right. Public or private, and then the type that it would be like. Static means that you don't need to say class. Okay, what do we choose now?
And decide.
And then it's a big JavaScript by itself.
And then on the next line.
The guy looking at says, I'm sure there's an important essay. I'm 2 pages in, and I still have no idea what you're saying. It's big, it's area. Your directory structure should match, as in what we have there, the column shape, and then for all your classes, and it shapes all the memory. And that will, there was one, I don't know, like there was, essentially, if you look at that, you see that tall, triangle. Yeah, well, so triangle and int, and then return side length. This dot side length equals side length. Take just another minute or two. How we doing? How we doing, front table?
Okay.
Making sense? Kind of, sort of?
So it's a big instructor triangle. Right?
Like every class should have.
That's okay. So I'm taking it like I did like a baseline variable, side length variable. So what would you want to take? We're going to
all values are going to be the same. Why have multiple values?
Oh, well, they were originally, but
Right. In this case, if you look at your tests, it's going to be triangle.
Oh, is it okay?
You can assume.
And then add triangles and triangle are coded. Okay, got it. Yeah, cool. We'll get that. Making triangle, passing line.
How you guys doing? Making sense? You doing okay, Casey? Not really? What are we confused about?
So the side length, we have to clear this.
Yes, your side length is probably gonna come, yeah, you're gonna need the variable somewhere.
To do that, it's double.
You could, so probably in construction. So with, remember, with classes, get unit, and they need to be told what to say. So what is the triangle, what is the piece of the triangle?
So it just be, yeah, so like.
That's two sides, that's it. So you need something in your constructor to say, here's what my side is. So we would call triangle, int, or double, or whatever you want, or whatever number. And then int side length, and then this dot side length. That's essentially what it looks like. It should look like, so you can see on the user, so it's got two, you just have one parameter, and with the int,
Okay.
and you'll have this dot.
And I would do that
And this is
inside.
assigning the value to that instance of the class. So anytime I call a class, it's called triangle with 2,000, and it'll build a triangle with 2,000 or 10 on the side, or whatever. That would make more sense. Some of it is just getting the syntax and the flow. It's very different. JavaScript objects don't need construction.
So triangle one is pretty much.
Yes, the triangle one is mostly.
So, not a statement. So. Alright, so.
Well, so you wouldn't do it here, so classes is just gonna be the way that it is. So take that out. And just do the structure here. So just write triangle. One parameter.
So that's the method. Here, you're trying to set this up, right?
And then just your this dot side, this side, this dot side, this side. Yeah. Then you can call side somewhere else. So here. That's the right idea. So then you need to make sure if you look at test dot job, there's two methods that they call. So make sure that this class has access to those methods. Probably just on the class. We're not building interfaces yet, so. All right. I connected with most of you. Let's look at some stuff together here. Okay. Let's look together at what a solution could look like. Okay? So this is our test suite, essentially. This is completely unchanged from what I gave you. So if we look at this, we can tell what our blueprints should look like. So we can see, in this case, we're instantiating a triangle. We're instantiating a square. We use the same new keyword that we're used to. Anybody notice anything different about the syntax on lines 8 or 9 from JavaScript? What's different about it? There's types. Yep, and absolutely, and that's exactly actually what I was getting at. If you notice, we have the class names right at the beginning, and then a variable name. So we're calling a type triangle and a type square. Those are classes, objects. New triangle, new square. That's very similar to what you've seen before. We're passing in a value to both of those. So what can we assume about our triangle and our square if there's only one value being given to it? all the sides are the same. So how many fields or variables do we need to represent side length in our classes? One. How many things should go into our constructor as far as fields? One. One field. Okay, great. So let's look first at our triangle class. This one was built out a little bit more than for you. Now there's some things in here that we don't necessarily need, but let's look at everything. So we have a couple private variables up at the top, using some common naming conventions. Naming variables with an S or an M declares them as members or static. It's just a naming convention, it's not required. But you'll see there's a private static variable and then a private final variable. Both of those we're not going to worry about too much at this point. But the purpose really is this top one here is to tell us how many sides we have. And then we have our side length variable. So let's look at our constructor. Triangle int side length, this dot m side length equals side length. That's it. That's all for our constructor. Our constructor takes in one value, gives us one value. And in this case, we're renaming it. You could call your, your variable side all you want. You just have to make sure you declare it as well. So you declare a private variable in this case. You just say int side length or whatever. Does that make sense? What questions do you have about this particular constructor and how it's functioning? Anything?
Well, we had thrown errors when we tried to do this. Maybe, I don't know, are you not allowed to have sides like this on sides?
What kind of an error?
It just said that you can't reference like
The same names?
static, non-static variables not be referenced static.
So it's going to want you to do different names.
Different names. Okay.
So that's a nuance of JavaScript. Really, JavaScript lets you just kind of call things whatever you want. Java and other compiled languages have to be a little bit more specific. So static variables within your class do need to have a slightly different name than what you call it in the constructor, which is why they put in the M side length. That's really the you could just capitalize it.
It should be able to work with six on that first.
Well,
I thought it was. I would have thought.
That's why I use this in order to, because if it's different, then I wouldn't use it.
yeah,
Yeah, I'm gonna have issues.
it's best to have slightly yeah. So our constructor is very simple. So let's look at our methods. We have an area method. It's going to be a double because how do we figure the area of a triangle? Yes, half the base times the height. Exactly like we got it there. So we're returning 0.05 times side length times this dot get height. So let's look at get height. Get height is another method, and all it's doing is return this dot side length times math.sin dot 2 radians. Who looked up math.sin math.2 radians? Who can explain to me what it does? Anybody? Let's look it up together because we're all here. Math.sin. Java. So math.sign, in this case, java.lang.math.sign, we're importing it, returns the sign of the argument. So it returns some math. You guys all remember sines, cosines, tangents, etc.? Kind of. Rich probably does. How else could we get the height of a triangle? How else could we get the height of a triangle if we're not using a sign? Using algebra. So you can do algebra here instead, if you wanted. You can do, there's lots of math in programming. Lots of math in Java specifically. So that's what get height does. It just gets the height. Then we have a perimeter method, which does what? Takes the side length and multiplies it by the number of sides that we have. Could we just do this dot side length times 3? Because it's a triangle? Yep, that'd work. And then the get sides. Get sides is only because we assigned this. If we don't have this, then we don't need. Tim. So you're talking about just renaming the variable?
Yeah.
It's a best practice. It's a best practice because you can run into compiler errors if you're referencing a static value in a dynamic context. Okay. Or the other way around, dynamic value. All right, cool. Does everybody make sense with what we would do for our triangle class? Yes, no, maybe? Kinda? All right. Fairly simple. So now that we've been through our triangle class, we could see what our square class would look like. Again, in this case, we're assigning a value for the sides. We have a side length value and our constructor. What's different about our constructor? What's the difference between a square constructor and a triangle constructor? Square has 4 sides, but the constructor. There's nothing. There's no difference between the square constructor and the triangle constructor. So they're both taking in one value and then returning a value, well, not returning, but setting a value based on the value it receives. So if I call square, new square with 2,000, what is my side length going to be? Really long? What would it be? If I call a new square with 2,000, what will my side length be? 2,000. 2,000. If I called it with 342, what would it be? If I called it with 3.14159, what would it be?
Hopefully you said it as a double.
Well, yeah, in this case, it'll error because it's looking for an int. So we need to call what kind of a value?
Yeah, it would be an error.
You could do a float, or you could do a double. Huh? It has to do with the length. It has to do with the length of the character. So a double can have, what do we determine? A double is 64 bits? Yeah, a double can have 64 bits where it's a float.
Because I think everything points to double.
So then if we look at our class, we're going to see some very, very similar things. In fact, less here, because we don't have a funky get height. All the sides are the same, right? So we have an area, we figure that out. We have a perimeter, and then we have the get sides, and the sides just reference the sides. So any place where you see the s dot sides, you can just replace that with a 4, and you'd be fine. Unless you can make a square with more than 4 sides. What questions do we have about this exercise? Other than I don't get it, I don't get it, I don't get it. Bang, 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 head on desk. Like, let's get into it. Michelle, questions?
I think what's kind of confusing is that I'm used to putting a function of like area and perimeter inside your square. Right? It's like, it's weird.
We still are. Here's the mind shift that you have to get through.
Inside the square class.
We're inside the square class, which is, in this case, an object. So we have our class, and that class wraps everything. The constructor is on the square class.
Because the constructor is always the same as the class, so it seems confusing.
Right.
Since in JavaScript we use the constructor to define,
Let's
like you're saying, those methods. But in this case, we're using the class that way. So your constructors are always named the same as your class. So it kind of, I see that confusion.
Yep.
When you compare it to
Easy to confuse, because it is very different.
Yeah.
So
In
this-
JavaScript, you're typically calling them constructors or something like that, rather than the classes.
the second, the square below the side link variable
Mhm.
is really your constructor.
Mhm.
But so to me, your constructor is building out everything, so I still don't understand how come your functions within that constructor
When your
within
class,
square.
the class builds out the constructor, when you want it to do is set whatever you need, a basic setting that all those objects that you created a square will share. So in this case, you're passing
Oh,
in a
so it's
length.
just whatever is
Mhm.
gonna be shared within the other functions or attributes.
Within the class, typically within the class.
Right, so whatever you
Constructors
want.
build out what's inside the class.
Exactly, so whatever you want to set to a certain length or whatever attributes you can set specifically that you're passing in. You put in the constructor. The constructor is basically, think about it as, once you create an object, this is what I need to have every time. That's what you're doing. So every object that's created, I need it to set the length to this, set whatever attributes to another value. That's how you should do it.
Why you gonna like, why not just pass in all your values? Why do I have to reset the side link to this guy?
Because
And that's,
your end side length, right, is what's in the class. That tells it every single square object that you might create will always have that attribute and side length. And then the side length you're passing into that constructor just gives it that. Because it might be different from another square. So
You have
each square,
a square that's not 10 length, but 5 or 5,000 or a million or whatever. The reason that we rename the variable there, renaming the variable is because Java's finicky, and you can't reference a dynamic, reference a static variable in a dynamic context. So this is a static variable.
changing the value of it.
Yes.
Dynamic.
If we rename it, we now have a static variable. We have a value that doesn't change. Essentially, that where it says private final int, if we want to translate to JavaScript, we're saying const. So we're making a constant from a dynamic thing, why we're changing it.
right, so you can never change it again. Only in that constructor where you're assigned. You can only assign it.
Yep.
You use that equal sign, basically.
Yeah, it's always gonna be side length, but side length can change.
Well,
The value of that.
it will never change it.
For a different class, for another instance of the class.
For another class.
Once you've built the class, constructors come out, those values are set.
Right, because that's just a placeholder, right? Like, just like in a function. You know, that side length could be named whatever. Right? Inside of that constructor. You're
All
setting it
bacon.
once. What was that?
All bacon.
All the bacon, yeah, absolutely.
Well, everything is.
I gotta get my bacon jokes in.
Right, so you're setting it once, and then after that, it's like your class. But you can only use that side inside that square. After that, you never
see
set it. You're not using hand side for that matter.
So like in triangle, can you call your variable side length?
Sure.
Still call,
Because it's a totally separate, object, it's a totally separate class.
The scope is basically just inside that square constructor. Anything outside of it can access that side of that variable that you pass.
And because we call this a private variable specifically, it cannot be accessed outside the class. There's no other class in the world can access that variable.
You need to get it.
You need something else to get it off of square and be able to assign it to your value. Does that make sense? Does that clear things up a little bit for you? Good questions, great questions. Java is very different, and it's not just syntax. When we get to do our class on Python and Ruby, you're gonna see lots of just like, oh, okay, it's the same. It's just different syntax. Java is a much more, I don't want to say convoluted, but it's a bigger ecosystem. There's more rules. JavaScript has almost no rules. Java has tons of rules. Paul, correct me.
So area, perimeter, and get size and stuff are all just basically like properties of the square class, right?
Yeah, they're all methods.
So I guess my first instinct was I would not have made them like a method per se. It would have just been like, oh, well, square's gonna have a variable called area. So I would declare double area and then use equals. My square, so like length times height.
Okay.
Like, why is that then?
Because you want to keep your attributes up top to a single value. You don't use, well, the way I learned is better to do those calculations inside of a function or a method inside that class. So if you ever needed to get the area, you would instead of calling it, because you want those attributes to be private, right? Your area to be private to that. You would then need to make that static for you to grab that area or make it public, and that's where I get practice. Calculations make it a method, right? And then pass parameters.
And that's because it's like better practice, not that like it literally couldn't work.
No, it would work.
It can work.
It's just it's like not.
So here's the thing. What did I say at the very beginning of our conversation about Java and object-oriented design? Everything's in an object. That's one thing I said. Good job, Paul. We want to break it down. You want everything in the smallest possible pieces, including methods and things within your classes, because A, it makes it more testable, B, it's easier to debug, and C, you're going to make your life easier. You're following solid principles by keeping things to a single responsibility. So if we're setting and then resetting values all the time, our class can get confused and we can end up with mutated data. If we have a single value called Nick doesn't change, right? He is who he is. Maybe he changes his mustache or something. It's a totally separate class.
Yeah.
So those values, once that value's there, it's there. It's not changing. You don't want to mutate it.
Okay.
So we can do methods on it. We can change. We can get other values from that value, but we don't want to change that value.
Okay.
Because otherwise, I mean, think about taking your head off and putting Carmen's head on you. Now you've created an entirely different person that you didn't necessarily mean to because you just mutated one thing.
Yeah.
Your head is just a piece of your whole body, right?
Yeah.
So,
Yeah, like try to think of it as basic terms, like whatever you can do on that object, create a function. So like
build methods.
square by basic, the square, for instance, you know, it has size. That's it. Right? That's all you do. Now, if you ever need, I need to get the area of this square. That should be always be a method. I need the perimeter. Then that should be a method, right? It's the length will never change. That'll be there. That way you only have one attribute. Have that side length, and that side length will allow you to get other values.
Right. Yeah. And if you need to make a rectangle, you have an entirely separate process.
That can extend.
That would take two values.
Right. Yeah. Square would extend.
Well, I probably wouldn't extend
Or
square.
like an area, right?
I probably wouldn't extend the square with the rectangle.
Make a function.
Maybe we'd be able to put square face or something.
Alright.
We might, the only thing we do there is maybe build an interface. And you can
I'll
have
get
it.
it.
Michelle, what's your question? Yep, let's look it up. Let's get the exact definitions together. Final variable Java. In Java, we use the final keyword to specify values that are not to be changed. It's like calling const.
We not put them, are you used to always put under caps. Is that not a thing?
You can do it. That's just a code style.
And then the,
Differentiate how we know your code. That's
on the bottom thing where you're saying int get size, return square, the square that you're really calling the class.
Correct.
square?
We're saying the class that we have, call the size variable. Right. In this case, could we replace return 4 with, and just take out that variable at the top? Yes. We don't have to define that, but we are in this case.
So that's a little bit too, and then we've got square defined as a constructor, but it's also a class, so
Yeah.
the variable of the class, not the constructor.
And this is why with these, with C#, with Java, with other compiled languages, object-oriented languages, you want to make sure that your classes always are capitalized. So you call square, uppercase square, you know that you're referencing the class versus a lowercase square or something like that. It helps you keep your code straight. So when you see that same name as the class, you're actually referencing the class that you have. It's a big object. Classes are objects, objects are classes for the most part. Not always, but for the most part. In this case, that's exactly what it is. This class creates an object. That's what it does. Other questions? Good questions, everyone. This is a great discussion. It's a very, very different paradigm. Yeah, John.
I was looking at other documentation, it seems this doc is not necessary. Or just, I guess it's optional.
I don't know anything about that. I would always use this.
Okay.
This in Java is much more constrained than it is in Java. Because your scoping is much more. So you don't have to worry too much about the random this collecting global variables, because global variables essentially don't exist in Java. They do, you can create them, but you create them in a very specific way. It's very hard to have things bleed into that particular scope. So outside of the class hierarchy. Cool. Questions? How are we doing on the stream? Anyone still listening? Maybe? All right, let's keep moving. Good job, everybody. That's fantastic work. All right. Okay, so we reviewed that. Moving on. All right. Cool. So we've learned all about classes, and we know how those work now. What if we need to create a class of a class? In Java, you can actually have subclasses, child classes, essentially. Think about our React work, right? We have components, and we have child components. We have grandchild components. If you create a child component, or a child class, sorry, child class of a parent class, what does that look like? Well, let's look. So in this case, we have 3 classes defined, right? We have an animal, we have a cat, and we have a dog. If we look at the cat and the dog, we see a keyword there when we're declaring the class dog extends animal. What does that mean?
Inheritance.
Inheritance. What is inheritance?
It's gonna have all of the attributes of animal plus whatever is not in here.
Right. It's going to get all of the stuff that's on your animal class and put it into your dog class. So what does that mean? Let's look at our animal class. So in this case, we declare our animal. We have a private Boolean of fed, and we have a protected final string name. So a variable called name that cannot be changed. Then our animal, on line 15, what are we doing? Andrew, what are we doing on line 15?
we're making a constructor that's taking the name and setting it.
Boom. We have our constructor. So again, our animal constructor is very simple. It takes a string and gives a string. That's it. Then we have some methods. What does void mean? Paul.
Void means something.
It means something. Good job. It means something. Yeah, what does void mean? Hell no. All right. Let's put it out there. Saul, what does void mean?
I forgot the term, but it's like in the same category as like static and it just doesn't return anything.
Yes, it returns nothing. So it's a function that returns nothing. Whenever you see void in Java, remember how we declare variables, how we declare functions. We declare them by the type. With a function, it's the type that we're going to return. If we're going to return nothing, we declare it as void. So in this case, what does the function of the method move return? Nothing. What does it do? Yes, it prints. That's all it does. It prints something out for you.
So what's the point?
What's the point? What do you mean?
Well, I mean, like, it doesn't do anything, it just tells you that.
Well, it gives you a message. It does something.
Well, yeah.
It doesn't return.
You don't need it to.
Yeah.
Oh, okay. Yeah. Anytime you have a function that doesn't have an explicit return, you use void. So if you've got a function that just maps, takes in values and assigns them.
It's a sign of real friendship.
The void is just that JavaScript is explicitly typed, strongly typed. So you have to declare the type of everything. Your variables, your function, returns, etc. You have to declare it. So again, we see the same thing with the method feed. There's no return value. It's just doing what? What does feed do, John?
It's setting this set true.
Cool. So it's just changing a value on the class.
In JavaScript, when you let's see your console.log function that didn't return anything, it would not throw an error. It would just print on the line. I'm guessing in Java, if you try to do that, it would throw an error because you're treating it as if it will return something when you're inserting it.
So you're trying to log. So if I wanted to print feed,
right, or just like something plus feed.
Like print a method. You know how to
oh, okay, just print the method. Yeah,
Might throw an error.
just print and then somewhere else in the main, you use the print
and then print
that
feed.
class, that feed.
Yeah,
It's not returning anything.
I don't know what it would do, to be totally honest. I've never called it functions. It's, you do console logs and stuff so differently. In this case, this function doesn't take any parameters. So printing it with just, the only thing you're going to get is the output. The only output from that is the change of the Boolean and then your print line. For what? What's it going to do?
So if something happens, then print out.
Great segue, Jeff. So Jeff asked, why would we have a function like move? And here's exactly why. So we have our animal class, right? Let's look at our cat. Our cat extends animal. So what can we assume about a cat? It's an animal. It has the properties of an animal. It is a animal. If we look at our test, let's see, does it have a good example? It doesn't have a good example. Let's use this. So in this case, cat is extending animal. So cat has everything animal has. So could I reference cat.move, essentially, and call it? Why?
Move the dog.
No, move is an animal. Move is on an animal.
Move the animal, you can call it.
Yes. So why we would put a function like the animal move or is fed that just returns void in the animal class is so that child classes could get to it. By extending the class, I'm getting everything that was created on animal. Yes, this blueprint extends other blueprints. If we want to think about a house, in this case, the animal is our entire house. The cat would be one room. So it's a piece of the house. And well, that's actually a bad example because that would mean that the room had the whole house in it.
A cat and a dog can both call the animals.
Exactly. The cat and the dog can both reference the things that are on animal. So both of them will have move, feed. Cat and dog. But we don't have to rewrite those functions. Those methods already exist when we instantiate a new dog or a new cat. Does that make sense? So let's think back to the activity we just did, right? So we created squares and triangles. Squares and triangles are made of the same thing, right? Which are what?
Dots.
Sides. You know where I'm going with it. Sides or lines, we'll call them. Sides or lines. So if we wanted to make a parent class for a square or a triangle, what might we call it? We call it shapes, but that would be a little more broad. Lines. Exactly. And so a square could extend lines and then get values from the lines class. Now, in that case, they're relatively simple. We could take that even further if we wanted. And what are lines made up of? Dots or points. So we could create a class dot and then extend dot into line and then extend line into square. And then we would have a square made up of lines which are made up of dots.
So for that syntax, like with this example, let's say you made a class mammals that extends out.
Okay.
And so we were making a dog, and the class dog extends mammal,
Yes.
and it would have everything that the mammals had, the mammals would have everything that the animals had.
Yep, absolutely. Absolutely. So there's a hierarchy that's built through classical inheritance. Here's the pratfall. Let's think about building a vehicle. Last example. If we want to build a class that builds vehicles, what do vehicles have? Vehicles have wheels. What else do vehicles have? Doors. They have bodies. They have an axle, let's say, instead of a body. So we've got three things: doors, wheels, and axles. Let's just make it that simple. So let's make a car class. What can we do with a car? We can drive it, but so our cars extended our vehicle class. So we got doors, we got axles, we got wheels. Cars have all those, right? Good. We can add a few other things that a car might have. A car might have an engine. A car might have a stereo. And those are unique to a car, right? All right, let's make a bike. A bicycle. Bicycle's a vehicle, right? All right, cool. So a bicycle extends vehicle, and now my bicycle has wheels, axles, and a door. Uh-oh. How many bikes do you know that have doors? Very few, or fancy ones. Maybe ones in like Thailand or something, where they're carrying their whole family in it. You know? I don't know. The little tuk-tuks or whatever.
Yeah, tuk-tuks.
You ever ridden one of those? It's like taking your life in your own hands. Like, it's just, holy cow.
Is this the part where object-oriented language is ruin lives?
Yes, this is the part where object-oriented programming ruins lives. So you have to think about when you're building out your inheritance trees, that your base classes, whatever you're extending, remember, everything you put in that, you're giving to all of the children. Every single one. So if you don't want a bike to have doors, you can't make it a vehicle. Or your vehicle can't have doors. So now you have to put doors somewhere else. So you have to make you want to keep tight couplings on your classes so your classes are nice and encapsulated. So as you're inheriting, you don't end up with things you don't want to have. They call it the gorilla banana problem. What you asked for was a banana. What you end up with was a gorilla holding a banana inside of a jungle.
You guys ever get eloquent JavaScript as a first name?
So object-oriented design and programming is really useful because it helps us write less code. However, it's not just magical. We can't just extend things until the cows come home because we're going to end up with a lot of stuff in our classes that we don't need.
Right, plus like, if you find that there's an error with the forest or with the jungle, and you only found out about it with the banana, you have to go back and you have to change the jungle class.
Yep.
Well, then you have to change all the children that were using that error
Yep.
error code ends up getting affected.
Yep, absolutely. Absolutely. So classes, subclasses. Not too crazy, right? Let's look at our next activity. I'm going to send out some files to you. We're going back to shapes, so you probably want to put this into a different set of directories. With these files, let's look at them together really quickly. Subclasses, up on this. Unsolved com shapes. Square test. The build and run are just for your own purposes, should you want to use those. But here's our tests, right? So we create a new triangle. We create a new square. Same sorts of things. When we look at our square and our triangle, am I giving you the right files? I am. What am I doing? So your mission is to create a parent class for your square and your triangle, and have your square and triangle extend that parent class. So you want to think about the similarities between the two and put that in the parent. Sort of like what we do with the animal. The animal can be fed. The animal could be, what were the other things that it did? It could move, it could be fed, it had a name, it had an is fed thing, and those were all part of it. Think about your square and your triangle, what the similarities are, and build a parent class to extend from. Does that make sense? Work in pairs, work in groups, that's fine, I don't care. The point is that we're getting some practice with a different language and extending our knowledge. Okay? Ready, set, go. So again, your job is to create a third class. You could even just call it polygon or shape and build from there.
So we're going to do some classes that extend.
Mm-hmm. Okay. Yeah, I'm just kind of going through stuff. I'm not.
Yeah, we don't have to go through all of it. Like, we don't have to follow just go through what's important.
Yeah.
I think we have extra time.
What else? Where are we supposed to end today?
Printable interface.
So what activity is that? 07?
Yeah, I won't say so.
So we'll do this. We'll take lunch and then we'll do interfaces.
All right.
I think.
I don't know how important that is, but
Interfaces are important.
and it's not. Well, once again, it's hard. Always hard to figure out whether it's easy or not because I know it already, but I don't remember too well how I learned it. Although I do remember having some trouble.
Yeah. Yeah.
But it was something going on with the way the call was being made. Okay. The API, as far as I've gotten so far. So it shows the loading when it's loading the data, and then it'll give you the list. I didn't fill out all the details, but for this one, let's say you're doing that right, it'll close this one.
Okay, great. I knew I was supposed to get something. It's always something stupid.
So now when it comes one of them out, I'll just make the call here, and then so the initial state of characters is loading. So if the characters is loading, it just shows the loading, showing loading, and so it'll display that.
Okay, I see.
And then once that call is made, so the state of characters, and then once it's there, then display the actual list.
Right, okay. And then you're passing, that's how you're getting it then into a component.
Yeah, so here, so I changed the structure a little bit
Yeah.
to maybe something that might work. And usually what we do is like, let's say in our components, we have.
You have a
like,
subdirectory.
yeah,
Yeah, I thought about doing something like that. I just, because everything is part of this.
Yeah, exactly.
I did was like, whatever, it doesn't matter.
Right, exactly. I figured, but I just did it so that it's structured. So I don't know if
That's super helpful, because
Okay.
I was at that point where I just stared at it.
So,
I just don't, what am I friggin' missing?
yeah, it was the actual where I got stuck was the API call because it wasn't returning a promise to me, so it wasn't I couldn't update the state based on that. So every time I tried,
Oh.
so every time I was like, why is it not giving me the data? Like it's not re-rendering.
So it's not, but this is,
So
we're doing this within this instead of in a helper.
in a helper,
Right, because
You could do that, but the way
it's probably because, again, I'm not creating an action story.
Yeah, no.
I'm not building a state management device.
Yeah, so normally Redux is like, okay, I'm going down the road, passing all the stuff, and then once you make that API call, then once it's finished, it'll pass those new properties down. But here, in that case, it wasn't happening. It wasn't
Because
re-rendering.
I wasn't building a store. So I was trying to be too clever.
But I don't know if you want me to just send it to you, or
Yeah, if you want to just
create a pull request.
yeah, that's
Pull request? Okay. Well,
and I'll refactor and stuff from there. Okay, I appreciate it, man.
yeah, no problem. No, I know. I get it. Same too.
I was like 3.5 hours yesterday. I'm just like, that's how far I got. So I feel like pretty good for 3 hours, but I'm like,
I'm forgetting something stupid, I'm sure. I haven't downloaded for committee and tried running it and we're getting some errors. Did not find load main class.
yeah, for sure. So trigonometry cannot find loads in platform shapes. Safe. Stats, you got your everything as far as active.
Yeah, we downloaded the JDK. I haven't attached it to Eclipse yet. I was wondering if that's the
That's
problem.
probably part of it.
I can't remember how to do it.
Yeah, I don't remember how to do it either. The other thing that you might want to look at is the comms, is your directory structure. Make sure that com is a parent and shape is a child.
So this package,
It should be, I mean, it's packaged, so it should be okay. But that's not, that's the other, that would be the other dumb thing to try.
it's like I just automatically had to add it.
Yeah. If you haven't put the JDK into, Rich is using Eclipse, so you might ask him, and he's got it working really well. So Rich is here in this front corner with the Hard Rock Cafe shirt on. He might be able to say, oh yeah, you got to do this, or can help you get the
It's been so long since I set up my Eclipse.
Yeah. to get the JDK going.
I just thought that if we did this here, would have told us that. So.
Yeah, like that.
Hey, Rich.
When you're setting up Eclipse, did you have well, if you already have installed processing, it's easy. They want to use Eclipse. I use them.
I guess
You guys trying to install Eclipse?
Yeah, we're just trying to solve an error that we got. Just could not find loads or load